Hey, everybody. Thank you for tuning in for Mondays with Mike. It's my day off, spring break time. So, just spending some time with the kids and taking a few days of relaxation before going back to work Thursday. I have a little, if you're joining me for the first time here for Mondays with Mike, this is the fourth one I've done. And my vision is just that it's going to be sort of laid back, casual, where we talk about stuff and obviously weather. I mean, like, for example, on my agenda today, we're going to talk about the chance for severe weather Monday night into Tuesday morning, basically over the next 24 hours, depending on when you're watching this. But also some other little things going on. We got the rodeo going on. We got all kind of fun stuff. And I kind of want this to be a little bit of a interactive, so you guys maybe could leave comments or ask questions and I might answer them, or you might tell me something, that I didn't know, you know, that kind of thing. So, anyway, the first thing, so on the agenda today, and I've made a little list here, we have, I got to talk about Dr. Jim leaving, Rodeo Carnival tips I'm looking for maybe from you. We got baseball season, which is back on. We have a new puppy in our family, not in our house, but I think I'm like an uncle or something like that. And then we're going to talk about the severe weather chances that Lena Maria and JD are going to be dealing with here over the next 24 hours. So first things first, Dr. Jim Siebert. Okay. Dr. Jim, so back around 2007, 2008, back in the old days, because, I've been here a long time. And back in the old days, our chief meteorologist, who you may remember, who was a wonderful, wonderful person, Cecilia Sinclair, she decided to leave television. So it left us with a void. And I was a whippersnapper at the time, and I really wasn't quite ready, to be in charge of everything. So anyway, here comes Dr. Jim, and he's just an impressive guy, right? I mean, he's just an impressive guy. So he came in, and that was 15 years ago. And Jim, I mean, has led the department since then, for the last 15 years. If you hear airplanes or something, it's because I'm sitting on my back porch enjoying the sun today. Jim is he's a good guy. He's a good man. He's very good at prioritizing things like, when we're having a hurricane or severe weather event. He was really good at, first of all, making sure we didn't get burned out, but also, just prioritizing what needs to be said, what needs to be communicated in a personable, simple enough way, where you have enough information to be prepared, but he's not trying to show off, and that's what I like. That's what I like about him. So Jim, I don't want to go into too much detail, I suppose, but Jim, if you didn't see his last day, the bottom line is his kids are grown. They're in the mountains. They're in the Rocky. They're not in the mountains. I mean, they live in a city, but they've basically moved out west. And so he's going to seek greener pastures or rockier pastures out there. And so there'll be a void that needs to be filled. And we'll see how that works out. But the bottom line is just be nice to JD, be nice to Lena Maria and me. We're going to be a kind of 3-person department for a while. We'll see. So that's what's going on with Dr. Jim. So I don't know if he's watching. Jim, you're a great guy. And I know you're going to enjoy your next chapter in life. In happy news, baseball season, how there was a lockout and we didn't know if we were going to have Astros baseball. So I'm ready for it. Got my Astros mug that we're actually going to have baseball. I know they canceled a few series, so it's not going to be like a full baseball season. The Astros are one of the favorites to win the World Series, actually, which is kind of cool. But oh my gosh, the boss is calling me. Should we get this on video? Hold on. Hello. That's okay. Hi. Uh, no, not necessarily. I'm trying to be as flexible as I can given the current situation. Oh, I didn't have any specific plans. Do you mind too much if I call you back like in 10 minutes? Just because I'm actually recording my Mondays with Mike segment right now. Okay. Okay, sorry. Bye. That was the boss. So I'll call her back. She was just asking about time off that she's trying to organize everything. It's a lot. So anyway, so baseball season, that's good. We're going to see if we can keep Carlos Correa, who we really need to keep. Rodeo Carnival, I plan on taking the kids to the carnival on Tuesday. So if you're out there, say hi. Um, I'm not real germy, so like I like hugs. You want to come up, give me a hug. If you want to give me a bro hug, that's good. If you want to give a fist bump, that's fine too. So we'll be out there on Tuesday. We have a new puppy in the family, Zara, and I'm going to put up a picture here. I think Zara is an Australian Shepherd who was just adopted by my brother-in-law, and his in at his house. We drove up there to his house yesterday, and the dog is just this is a beautiful dog. She's like a show dog, amazing. You got the one blue eye, one brown eye, and these. She has like an undercoat, like underneath it's like tan, and then on top of that she has this. She almost looks like a fox or a wolf or something. She has this like gray long hair with black spots in it. She's just really a pretty dog. So, um, yeah, so that's what's going on with that. Okay, so what I'm going to do right now, bear with me. I'm going to switch over to a web extension that I just downloaded that should allow me to show you, because I want to talk about severe weather and what goes into our forecasting. What are some of the things we look at that tells us, okay, we need to be on alert for some severe weather. So there's going to be a transition here in a second, kind of thing. So I'm really hoping this works because guess what? I just recorded like 15 minutes worth of me talking, and then I went back and my face was not on the screen. It was just, I mean, you guys could see what recorded was the desktop, but my face wasn't there. Not that you want to see my face, but I mean, it was like just the desktop. So you couldn't see any of the gestures or anything I was making. And so I'm going to just do this all over again. So when we talk about forecasting severe weather, just starting with like the basic is that um, in addition to what we're looking at, we take a lot of our cues from NOAA and the National Weather Service. And what you're seeing on the screen right now is the Storm Prediction Center, which is the National Weather Service. It's like a special branch of the Weather Service that's based in Norman, Oklahoma. And they are tasked with issuing watches and warnings, things like tornado watches and tornado warnings. They also do what are called like mesoscale discussions, where if there's an ongoing strong, line of thunderstorms, they'll update that. But in this case, I just wanted to show you the threat level. So for tonight, we're in that little dark green area and yellow area. And I show this on air from time to time. And so what it is it's a category of risk. And I don't like the way the categories are named, which is why we try to categorize them like 1 through 5, with the dark green being 1 and that magenta color being 5. The reason is that the way they're categorized is like this: marginal, slight, enhanced, moderate, and high, as far as a severe weather risk. Slight is like kind of a big deal. If you're in a slight risk area, you're at a severe weather risk. So slight sounds like, probably not. And I don't really care for that. If you're in a moderate risk, if we were in a moderate risk, that would be like almost practically we're sleeping at the station, which is, that's why, moderate doesn't even sound that bad, right? High risk happens almost never. I mean, maybe once a year. like literally maybe once a year, and rarely here in Houston. So, anyway, this is like one of the things that catches everybody's attention and says, okay, we need to look a little bit closer. All right. So, I really hope this is working. Okay, so I want to talk a little bit about computer models and how we use them to forecast weather at all, but in particular, severe weather. And just a little bit about some of the models that you might see on TV. You might see us show. So, our main forecast model here in the United States of America is called the GFS. And if you hear noises in the background, by the way, I'm outside because it's beautiful. Pippin is running around like a maniac. There's somebody's like cutting with a circular saw over there, you know? So anyway, the main model that we use here is the GFS, which stands for Global Forecast System. And it's the main, system of models that we have here for the USA, but it's a global model. And if you think about it, like, it's unbelievable the technology that goes into it. You have literally a supercomputer that is crunching numbers from taking data from all over the planet. Data that comes from satellites, from airplanes, from ships, from surface reports, from weather balloons, like everything. It's called data assimilation. All that data gets plugged into the models, and then it uses a lot of really sophisticated math to break up the atmosphere into layers vertically and horizontally. And then it takes about 3 hours to run the model. So you figure you've got some of the fastest computers in the entire world, and it takes them 3 hours to output the model. So it's intense. So anyway, what you're looking at here is the GFS computer model output, and this was run actually at midnight, which we call 6Z time. It's 6 o'clock Universal time. Sometimes it's called UTC. Sometimes, like in the old days, it was called Zulu time. 6Z. So this is giving us the computer-generated estimation of what the radar will look like. You hear Pippin barking? Dog, Pippin, stop it. I'm trying to work here. So this is the model generated radar, but that's not really the fun part. So the fun part is when you start looking at the more complicated things like the jet stream. Okay, so I'm going to pull up the 250 millibar wind. So this is about 35,000 feet up in the atmosphere, and it's showing us wind speed. Okay, so on the side, you have this legend that shows you that when you're in the orange and red area, like we have here over Texas, you're at about 100 to 120, and that's knots. KNOTS, knots. People say, what's a knot? A knot is 6,000 feet, and a statute mile is 5,280 feet. So a knot is about 1.15 miles per hour. So like, for example, 100 knots is 115 miles an hour. So it's just that the convention of knots is that knots are used to describe wind speeds very often. They're used by pilots to describe their airspeed in knots. So it's just the standard, it's a tradition. Scientifically, you would use meters per second. That would be like, if you were actually performing science, you wouldn't describe knots. You would use meters per second. But anyway, so this allows us to see the GFS projection of the jet stream. And what we see here, if you look real close, in the middle part of your screen, there's a dip. So like on the left-hand side of your screen, there's that purple area that goes up to Canada. And that's what we call a ridge in the jet stream, where it goes way up. And then it takes a dip over the central part of the US. And it's that dip that you see, that what we call a trough, that's driving the chance for severe weather. Now, right now, we're at about 35,000 feet. I'm going to take it down to about 18,000 feet, and we call that 500 millibars. And this is an important level for us because we look at something called vorticity. What in the world is that? Well, it sounds like a really complicated word, but it really isn't. Vorticity is the measure. You know the word vortex, right? Vortex means a spinning, something that's spinning. Okay, like if you drain your bathtub and it spins, that's a vortex. A tornado is a vortex. A hurricane is a vortex. So this is measuring how much of a vortex. If you were to pick any point, how much of a vortex is that point? Vorticity is like vortex-ness. The reason this is important to look at is that the mathematics that goes into the atmospheric dynamics tell us, without going into too much detail, that where you have the vorticity moving in, we call that vorticity advection, you have lift in the atmosphere. So I'm going to zoom in here on Texas and show you here that as of 6 p.m. tonight, you have this, just look for the big streaks of red, okay? The big streaks of red are where there is high vorticity. And then you want to look at where is it moving to, because that's called advection. So you have this area of vorticity, but where is it moving into? And it's moving toward us. So I'll put Houston right in the middle of your screens. It's moving right toward us. So that's one of the other things we would look at. Now, one of the downsides to using the GFS model is that it's low resolution. So like if I were to turn on, if I were to look at, oh, and by the way, the website that I'm on is called Tropical Tidbits. It's fantastic. And it's a user-supported website. So you could donate if you want to. You could use it for free if you want to, but you could like throw some money in the tip jar kind of thing. One of the downsides to the GFS model, one of the few downsides, is it's not a high resolution model. The reason it's not high resolution is it would take far too much computing power to have super high resolution over the entire Earth. It would take the model like a day, 2 days, 3 days to run. And then by the time you had the information, it would be way too late to use. So they have to strike a balance between being able to forecast 16 days out for the entire planet and having enough resolution for it to be useful, but not too much that it basically melts down the computer and the computer just melts on the ground. But it gives us a pretty good degree of resolution. So this is what it's showing for. This is what it's showing for tonight at 6 o'clock, and then I'll fast forward to midnight because that's sort of the time that we're looking at. Midnight, Monday night into Tuesday. So I want to show you the difference. So this is the GFS, which is a global model, and I want to show you what a high resolution model, how it differs. So I'm going to click on mesoscale, and I'm going to click on the HRRR or the HRR. So this is called the high resolution rapid refresh model. This is a super high resolution model, but it only goes out 18 hours. As opposed to the GFS that goes out 16 days, okay? So computing power-wise, you can have much higher resolution, have it not being global, just over the United States, and get the output in a reasonable amount of time. So you're going to see here much more resolution, okay? Much more sort of accuracy and precision. So the latest run here is showing us this is midnight. This is 1 p.m. Tuesday. So this HRRR model is showing us that between around 11 p.m., maybe let's call it 10 p.m., between around 10 p.m. and 2 a.m., we're expecting a line, what's called a squall line of thunderstorms to come through. So what that means is that, overnight tonight, we're looking for the chance for high winds, maybe some hail. Can't rule out a tornado, but we're mainly looking for high winds and hail. So anyway, without like going down the rabbit hole way too much, we'll do that in a subsequent episode. That's sort of what we're looking at when we take a look at the large scale models and the high resolution models. I hope that wasn't too boring. I hope that maybe is like for any nerds out there. None of you are nerds, right? But for any people that are really interested in weather, kind of weather geek kind of thing, or just want to know, like, how do they know, Because people will ask me questions all the time, even like close friends will ask me, so who tells you what to say, I'm like, nobody. Okay. Like, That's why we went to school, but it is complicated, and yeah, we do have some help. I mean, the National Weather Service is like an invaluable tool, both at the national level and our local office. And so, um, there's a lot that goes into it to try and nail down what time our storm's going to get here, how bad is it going to be? And sometimes with really fast moving systems like this, it's tricky because like you'll be sunny and then it'll get stormy and then it'll get sunny again. So it looks like tomorrow's weather is going to be nice enough for us to go to the rodeo. So that's what we're planning on doing. Anyway, thanks for joining us here for Mondays with Mike. Once again, goodbye to Dr. Jim. Great to have worked with you for the last 15 years. And that's it. So hope you guys have a great day. And if you see me at the rodeo, say